Today we're going to be talking about antennas. We're going to cover a lot of the basics, the different types of antennas, how to read an antenna pattern plot, and especially how to visualize antenna coverage in 3 dimensions. So we're going to be talking about 5 different types of antennas today, starting with the basic stick omnidirectional antenna, moving to another type of omnidirectional antenna called a squint or a down tilt antenna, which is pretty interesting. And then we have 3 different types of panel or sector, or sometimes indoors they're called patch antennas, that are used for different applications outdoors. So a basic skill that you have to have as an outdoor network engineer is to be able to read antenna pattern plots in order to select the proper antenna for a given deployment. Pattern plots are included on each data sheet for individual antennas that we sell, and they basically have 2 parts. So the first part is the horizontal or what we call H-plane, and the second part is the elevation or E-plane. So let's look at an H-plane plot. So you can see here that there's a 360-degree compass, and you can see kind of the shape of a sector or panel antenna. In this case, it's a 50-degree antenna, and many times we talk about degrees when we're referring to the shape of a pattern. So let's look at a couple of H-plane patterns. On the left, we have a 50-degree sector antenna, and on the right, we have a 120-degree sector antenna. And when we say 50 degrees or 120 degrees, what does that really mean? Well, that's referring to the distance between what we call the 3 dB points. The 3 dB point is the point on the energy plot where the power has been reduced by 50%, or 3 dB, from the peak power in the direction of maximum gain. And the difference between those 2 points in degrees is the horizontal or vertical beam width of the antenna. Now, if we look at the E-plane, it's exactly the same concept as we just talked about for horizontal, but instead in the vertical dimension.